we want to find out under what condition a line is going to, three lines are going to pass through a common point. Let us suppose we have three lines L1, L2 and L3. Now each of the three equations of the lines are given to us. Let us suppose that the equation of line L1 is given by A1x plus B1y plus C1 equals to 0. So here we are considering the general form of a line. For L2 to line 2, let's say its equation is given by A2x plus B2y plus C2 equals to 0. And then for the third line, let's say its equation is given by A3x added to B3y plus C3 equals to 0. So we want to find out the condition for concurrency. Concurrency means when passing, having a common point, a line that passes through a single point. To find out the condition for concurrency, all we can do is take any two equations of line at a time. For instance, let's pick up equation number 1 and 2, that means line 1 and line 2. We're going to solve these two equations simultaneously. That's going to give us the value for x and y. And whatever values of x and y we get, that must satisfy the third line. Only then we can say that the three lines are concurrent. So we begin by solving line 1 and line 2. For this, we'll be using the law of series. There are several methods to solve equation 1 and equation 2 to find out the value of x and y. Here I'll be using the law of series. For this, what we'll do, we'll start by considering the coefficient of y in the first equation. So that is b1. Then we are going to go to the next term, which is c1, the constant term c1. Now again, come back to the first term, the coefficient of x, that's going to be a1, followed by the middle term, which is b1, the coefficient of y. Then similarly, we'll pick up the coefficients and the constant term from the equation L2. So here we'll start with the middle term. So we'll take b2, which is the coefficient of y, followed by the constant term c2. Come back to the first term, we consider a2, the coefficient of x, and then end with the coefficient of the middle term, so b2. Okay. So here, what we'll do, we're going to perform cross multiplication. b1 is going to get multiplied to c2, and from here we're going to subtract the product of c1 and b2. That is going to be x. Then c1 will get multiplied to a2, and from here we are going to subtract the product of a1 and c2. That will be y. And then finally a1 times b2 minus b1 times a2, that we'll consider as 1, which means that we can now rewrite it as x over b1 times c2. We get b1 times c2 minus b2 times c1. b2 times c1, that is going to be equals to y divided by, here we'll take c1 times a2 minus a1 times c2. That is going to be equals to 1 divided by a1 times b2 minus a2 times b1. Now to find out the value of x, what we'll do, we're going to consider the first ratio and equate it with the last ratio. So that means x is going to be equals to b1 c2 minus b2 c1 divided by, we have a1 b2 minus a2 b1. And then we're going to take the second ratio and equate it with the last one, the third one. That is going to give us the value of y. So y will be c1 a2 minus a1 c2 whole divided by a1 b2 minus a2 b1. So that's x and y. So this is going to be the point of intersection of line L1 and L2. So we have the point of intersection, the x coordinate and the y coordinate. And if we are to show that the line 3 also passes through the same point of intersection, then this particular point must satisfy the equation of L3. So what we'll do, in place of x, we're going to replace it with the x coordinate of the point of intersection and y with the y coordinate of the point of intersection. So let's do that. So our line L3 is going to become, so we have a3 times, we need the x coordinate, so that will be b1 times c2 minus b2 times c1 whole divided by a1 times b2 minus a2 times b1. Then this is going to get added to b times the y coordinate. So y coordinate is c1 times a2 minus a1 times c2 whole divided by a1 times b2 minus a2 times b1 added to C3. That's equals to 0. Now we're going to further simplify. What we'll do, we're going to multiply throughout with the denominator of the first two terms, that is a1 p2 minus a2 p1, which means that we are now going to get the first term becomes a3 multiplied to b1 c2 minus b2 c1 added to b multiplied to c1 a2 minus a1 c2 added to c3 is going to get multiplied to the denominator a1 b2 minus a2 b1. That is going to be equals to 0. Furthermore, what we can do, we can distribute a3 with each of the two terms within the parentheses for the first term. Similarly, we can distribute b with these two terms within the parentheses and c3, and we're going to rewrite the expression. The new expression is going to be, we'll have a1 as the common factor, that is going to get multiplied to b2 c3 minus b3 c2. Then we have added to a2, so a2 gets multiplied to b3 c1 minus c3 b1 added to a3, so we have a3 multiplied to b1 c2 minus c1 b2. That will be equals to 0. Now this is actually the determinant, so this can be also expressed in a determinant form. This is simply, so we take a 3 by 3 determinant. In the first row we are going to have a1 a2 a3. In the second row we're going to have b1 b2 b3, and on the third row we have c1 c2 c3. This is going to be equals to 0. That's already given, that's 0. So this is actually referred to as the condition for, this is going to be the condition for concurrency. For concurrency, meaning given two line a1 L1 L2 and L3, if they passes through a common point, then what we'll do to check whether if it is true or not, if they really passes through a single point, we'll find out the determinant. In the first row we consider, we'll say in the first column we are going to consider the coefficient of the line L1. Then in the second column we are going to consider the coefficient of L2, or you can say the constant coefficients of L2, and then in the last column we are going to consider the coefficients of the line L3. And if the determinants comes out to be 0, then we can say that indeed the three lines L1 L2 and L3 are concurrent. Let's try to understand this with the help of an example. So here we need to show that the lines 3x plus y minus 14 equals to 0, that is the line 1. So let's note them down. We have the equation of line L1, 3x plus y minus 14 equals to 0. That's one line. Then we have the next line L2, that's it, that is given by x minus 2y equals to 0. And we have the third line denoted by L3, so that's 3x minus 8y plus 4 equals to 0. We have to show that these three lines are concurrent. To show that the lines are concurrent, what we'll do, we're going to compute the determinant, or the 3 by 3 determinant, where in the first row we are going to consider the constant coefficient. So here the coefficient of x, that's 3 for line L1, then the coefficient of y, that's 1, and the constant term, that's negative 14. In the second row, let's consider the coefficient, the constant coefficient of line L2. So x has a coefficient of 1, then y has a coefficient of negative 2. There is no constant term, so we're going to consider 0. Then for line L3, we have the coefficient of x, that's 3, coefficient of y, that's negative 8, and then the constant term, that's 4. Okay, now let's expand this determinant along the first row. So here we consider 3. So 3 is going to get multiplied to the 2 by 2 determinant, which is going to be negative 2, 0, negative 8, and 4. Then we have the next term, which is going to be negative 1. This is going to get multiplied to another 2 by 2 determinant. All you have to do is ignore the row that contains 1 and the column that also contains 1, which leaves us with 1, 0, 3, 4. And then we have plus negative 14, that is the third term, or you can say the term in the third row, first column. This is going to get multiplied to, we have to ignore the row containing negative 14 as well as the column that contains negative 14, leaves us with 1, negative 2, 3, negative 8. Okay, so let's expand it. So we have 3 multiplied to negative 2 times 4, that's negative 8. Negative 8 times 0, that's simply 0. Well, leave it aside. Then we have negative 1 multiplied to 1 multiplied to 4, that's simply 4. 3 times 0, that's 0. We have negative 14 multiplied to 1 times negative 8, so that's negative 8, minus 3 times negative 2 makes it negative 6, but since we already have a negative sign, we're going to get positive 6. So now we have 3 times negative 8, so that's negative 24, minus we have 4, this is going to be negative 14 multiplied to negative 8 plus 6, that's negative 2, so negative 14 times negative 2 makes it positive 28, and when we combine them, we're going to get 0. So what we're getting, we're seeing that the determinant comes out to be 0, then we can say that hence the three lines, hence the lines L1, L2 and L3, these three lines are indeed concurrent. That means they are going to pass through a single point. So that's what we had to show, and we have successfully proved it. Okay, let's do one more problem. Now in this problem, we need to find out the value of lambda such that the three lines whose equation are given to us are concurrent. That means these three lines are already concurrent, and we have to find out the value of lambda that makes it concurrent. Okay, let us begin. So here we have three equations of the line. So we are going to straight away compute the 3 by 3 determinant. So let's consider the first equation, 3x minus 4 minus 13 equals to 0. So the coefficient of x, that's going to be 3. So this is actually 4y, negative 4y. So coefficient of y, that's negative 4, and the constant term, that's negative 13. Coming to the next equation, we have 8x. So the coefficient of x, that is 8. Then we go to the coefficient of y, that's negative 11, and the constant term, that's negative 33. And then finally in the third equation, we have the coefficient of x, that's 2, a coefficient of y, that's negative 3, and we have lambda. Since these three lines are concurrent, the determinant must be equals to 0. Now what we'll do, we're going to expand this determinant about the first row. So we have 3 multiplied to, so negative 11 times lambda makes it negative 11 lambda, minus 3 times 33, that's going to be 99. Then we have negative of negative 4, so that makes it positive 4, multiplied to, so we have 8 times lambda makes it 8 lambda, minus 2 times negative 33 makes it negative 66, but since there's an already negative number, we get positive 66. Then we have negative 13 multiplied to 8 times negative 3 makes it negative 24, minus 2 times negative 11, that's negative 22, but there's an already a negative number present, so we have positive 22. This is going to be equals to 0. So let's now expand. So we have 3 times negative 11 lambda, so that makes it negative 33 lambda, minus, now we have 99 times 3, so that's going to be 297, added to 4 times 8 lambda, that's 32 lambda, added to 4 times 66, that's 264. Then we have negative 13 multiplied to negative 24 plus 22, so this is going to be negative 2. So negative 13 times negative 2 makes it positive 26. This is going to be equals to 0. Fine. Now we have negative 33 lambda plus 32 lambda, so that's going to be negative lambda. Then we can add all these up, add and subtract. That's going to leave us with negative 7. That's going to be equals to 0, which means that lambda value comes out to be negative 7. So this is the value of lambda for which the three lines whose equations are given to us, they are going to be concurrent. So this is how we can check for concurrency.